understand the problems that we solve with power line communication, and also to understand some of the limitations, right? Every technology has a set of limitations that you have to work within or get around. So that's what we're going to do. And also, in terms of definitions, let's just talk about network lighting controls, which is really the end use for this technology. And you could technically call 2 lights on 1 switch, or 2 switches on 1 light, you could call them networked lighting controls. But for the purpose of our discussions, the network lighting control really is a set of different types of devices, maybe sensors, maybe light fixtures, maybe switches and controls that are networked together to form a sophisticated lighting control system. So when I say network lighting controls, that's really what I'm talking about. Okay, so now, how many people in the room, any of you lighting designers? Or you have your lighting designers? Okay, well, whether you're a lighting designer or not, here's what I want you to do right now. Focus on this LEDucation sign right here. Don't cheat. Don't look down. Don't look up. And tell me if you know what kind of lights are in the ceiling right now. Anybody notice? All right, you get to look now. Compact fluorescence. How about anybody notice out in the hallways out there? Incandescent BR30s. And so what's my point about all this? My point is, this is an A building, a 2,000-room hotel in New York City, and it has not yet been retrofitted to LED. So the point behind that, to go a little further, is that things don't happen that fast in this industry. We think they happen a lot faster than they do. But the retrofit market's alive and well. If this building has, how much energy are you using with the hundreds and hundreds of incandescent lights that are out there in that hallway alone, and how many hallways are there in this building? So, why does it take so long? Well, I'm not really sure. But then, when you get to control technologies, which we first started hearing about at least 7 or 8 years ago, and they say, you know what, all the energy savings from LEDs, we're pretty much there already. We're really not, right? What's up? But the next thing is going to be controls. And every commercial building is going to have a sophisticated network lighting control system in it. And it's going to do everything from asset tracking to space utilization tracking to, I don't know, matter transport. I don't know. And that was going to be the next thing, and by now we would have another saturated market. So now, here's the thing. Don't let this graph, these kinds of graphs fool you. That's a graph of the potential or expected implementation of lighting controls in the commercial space over the next few years. And boy, that CAGR looks really good, doesn't it? It looks like it's just going to climb right up like this, like the Empire State Building. The reality is, though, the dark part at the bottom represents wired control systems. And how do they define a wired network control system? They basically let anything into that calculation. So a street light with a sensor on it goes into that number. Okay, they call it smart lighting. And okay, I'll give them that, it's smart lighting. But when we're talking about the proliferation of networked lighting into the market, we are not talking anything like that. And when you look at the level of blue, which is wireless, I think that's really optimistic. It's really optimistic. We all know stories of all the different lighting control companies, some of which are still with us, and some of whom we've had requiem services for. And the reason is that, well, actually there's a whole lot of reasons, so let me get into that. There's 4 continuous challenges that we face when we try to implement commercial network lighting controls. Residential is going along a lot better than commercial. And we'll talk about why in a minute. But the first challenge that we found is that about 8 years ago, I was working at Leviton, and then after that I was working at Maxlight, and we were designing networked controls. And there's a problem when you let the engineers run loose and design something like a network control, because we want to stick every little gadget under the sun into that system, okay? But who's asking for this system? Who's going to experience it? One of the problems is that those two individuals are different. The people who are specifying the system and the people who are using the system are two different sets of people. We are living, working, and playing in this space right now. We're the users of the system. What happens if the user interface looks like the cockpit of a 747? All right, we don't want to be bothered with that. As a matter of fact, if there's a really important client that's coming into the space and you can't get the lights to dim for a presentation, that system's going to get ripped out of the wall pretty fast and replaced with a light switch, which is what made everybody comfortable to begin with. So that's one. We're going to go through four. The next is cost and ROI. So these systems are turning out to be kind of expensive, more expensive than we thought. And even with the rebates, it's expensive because, number one, the lighting industry is kind of funny from the manufacturing side. We don't want to do a lot of design work. A lot of the stuff we're bringing in straight box in, box out from Asia or other places where we're importing it and we're just selling it, right? So when we ask for a sensor to go into our light fixture, we get a sensor with a 120 volt power supply in it, which is half the cost of the sensor. But isn't there already a driver in the fixture? So that driver is outputting the voltage that that sensor wants to see, but we're getting another power supply with that sensor and paying for it, right? So it's like having a car with two engines, one engine to run the vehicle and one to run the air conditioning system. And what's the point? And yet, we don't do the design work to design that out very quickly. All right, we've got development costs that are crazy high. 10, 15, 20, 30 million dollars to develop a wireless lighting system that then should cost a few bucks per fixture, but we got to recoup all that money. So anyway, I'm not going to dwell on that too long. I think costs will come down. Post-sale service, holy mackerel, right? Almost every network lighting control job that you put out there is a callback. Not because the system's not operating correctly, but because, gee, I went to turn the light off and it only went to 50%, and what's that about? And do I try to fix that? No, I call the lighting control company. And I say, what's going on here? You help me through this. So, or the contractor, who knows? Interoperability. People challenge me on this sometimes, but the fact that these systems do not talk to each other. I'm not talking about systems, lighting systems, talking to HVAC. That's a challenge in itself, but we can bridge that, right, by going through BACnet and things like that. I'm talking about if you buy a RAB light cloud network lighting system and you put it up in the ceiling, and then you buy a different set of fixtures not made by RAB, you've got no way to control them because whatever system they're selling is not going to work on the system you've got. Or, if for some reason Light Cloud is no longer supported by RAB, now you got a broken building. Right? This has already happened with Redwood systems. Where people put in all these Redwood lighting control systems into their buildings and Redwood went out of business. So that's number 3. And then reliability and security. So Wi-Fi is great. It does a whole lot of cool stuff. Okay, but it can be hacked from outside the building. No government agency will use it. Military won't use it. In fact, hospitals, schools, and classrooms probably won't use it. That's the security side. The reliability side is even more interesting. So in the residential space, the reliability issue is not that much of a problem. In the commercial space, it's a big problem. So let me try and first, I'm just going to run through real quickly the different types of network light control. We've got wired systems, which are the kind that are just going straight from the wall to a fixture and either turning it on, off, or dim. In some cases, you can do grouping, like with Dolly. You can do grouping and things like that. With wireless systems, you got 4 different kinds. It doesn't matter which one you're talking about. They all do the same thing. They just do it differently. And then you got power line communication. And where I think the world is going to go is to a hybrid system, because there's problems or opportunities with both technologies, wireless and wired. Okay, so let's keep our minds on that. And then 4 challenges: complexity, cost, interoperability, and reliability. And which ones can we tackle with power line communication? Okay, so let's talk about faucets and brains. It's a really simple matter to control an LED. All you do is vary the amount of power that goes to the LED. So the amount of power, if you give it full power, maybe that's 5 milliamps or something like that, the LED is going to be on full brightness. If you lower the amount of power going to the LED, it's going to dim. All LEDs dim. The reason that not all fixtures dim is because of the driver. The driver may not support dimming, or it may support a very specific kind of dimming that you don't have. Okay, so you got this for your control scenario, right? Now, if you are to go, this is basically the faucet. So you turn the spigot on the faucet, enough power goes into the LED, it goes on, it goes dim, it goes off. The brain would be something that sends messages and receives messages. Probably a computer chip of some kind that goes into it. And now you're getting into a little more sophistication, right? Because you can put a brain somewhere that can receive messages and control the faucet for you. Now, when we have a wall switch that's a 0 to 10 volt wall switch, for example, or a phase cut dimming wall switch that dims lights, okay, that's just a faucet. And if you put the faucet at the controller, you lose a little bit of control, because all the signals that go out of that thing are going to affect every single light in the room the same way. Right? So if I start lowering the power going through the system to lower the power to all these fixtures are going to behave the same way if they're all the same type of fixture, right? They're just going to all dim at the same time. So what can't we do? We can't do grouping. We can't do, let's just make this side of the room react to a sensor and the other side of the room not react to it. Can't do any of that. So what you need to do any of that is you need 2 brains, one at the controller and one at the load. And those brains will talk to each other, and they will get a signal that says, do something. And each fixture can independently do what it wants to do, or it's being told to do. And then commissioning is the act of explaining to the controller what you want things to do. Now, in a wired system, you have some limited capability. As I said just now, I kind of went through that. You got your power wires that are going to these products, but how are you going to control them? Well, in the case of a wired control, like 0 to 10 volt, you have to send wires. Additional wires through the walls if they're not already there. That's a big expense. We have some contractors we work with that are going into schools, 30, 40, 50-year-old school buildings. They don't have 0 to 10 wire in there. So if they want to use even a 0 to 10 volt standard Leviton or Lutron system at their walls, they've got to pull like $10,000 worth of wire. That's rough. Plus, they've also got the limitation that they can't do grouping, they can't do more sophisticated control. They can only control what's connected to that switch. So these systems include 0 to 10 volt, Dolly, power over Ethernet works this way, although it's more sophisticated, but it has to be wired. So how do we get around the wiring problem? Especially when it's really hard or expensive to pull wire. Well, we go wireless. We put little radios in each of the loads, and we put a radio at the controller, and the radio sends signals back and forth to each other and give each other instructions as to what to do. And that could be Zigbee, it could be Wi-Fi, it could be Bluetooth. Again, these are all just different protocols or languages of how those things speak to each other, and they all do pretty much the same thing. If you wanted to get into detail with that, it'd be a whole new seminar. So, what's the problem? Because actually Bluetooth wireless is pretty robust in terms of what it can do. It actually can send a lot of data really fast from one place to another. So I'm going to play you a video that I did when I was consulting that kind of explains it in a nutshell. Okay, and then we'll get back to me talking live. Okay, and this is not to disparage wireless systems. Where I said we're going to need them as hybrids, but this is reality.
I'm a huge fan of wireless communication technology. It opens up all kinds of new vistas for us. But all that added functionality comes at a heavy price, and that is in reliability. Let me illustrate. If we have a wired lighting system, that is a switch, a wire, and a light, and you hit the switch and the light doesn't go on, then there's only a few things that could be wrong. You'd probably think something's wrong with the light, something's wrong with the switch, or there's a loose connection somewhere. What you probably wouldn't think is that the switch and the light are no longer talking to each other because they've forgotten that they're supposed to be in a relationship and they need to be reintroduced. In a wireless situation, that's probably the first thing you would think. The second thing you might think is, gee, is my hub offline?
I'm sorry, I don't feel like responding to your commands right now.
Did the internet go down? Have I paid my subscription fees? Is something interfering with my system? In a residential situation, this kind of unreliability is an annoyance. But in a commercial situation, specifically in a school, a hospital, a prison, or a business, it could be a disaster.
See the problem? This is one of the big reasons why network control systems have not actually proliferated at the rate that the utilities wanted them to. Okay, so what's the solution? We got to get messages from a controller over to the lights. What if we could do it over the supply lines? So this technology, power line control technology, is the act of doing just that. It's taking digital signals and running them across the power supply wires that are already there. Nobody has to pull any new wire. Nobody has to reconfigure anything. And yet, you get a lot of the functionality of network control without the expense and the difficulty associated with pulling wire. So, why hasn't everybody done this? All right, so there's huge benefits. The benefits come in almost all the areas I talked about before. One is reliability. One is security. All right, so there's no wireless signal to be hacked. You could hack it if you could gain access to the supply wires, but that's the only one. Interoperability, I'm going to talk about how we achieve interoperability, meaning that we could take almost any manufacturer's fixture and configure it so that it works with power line technology. And then cost. So it is very cost effective to do this. It was not for a long time. So why isn't everyone doing this? Okay, so there's a number of good reasons why not everyone is doing this. One is, it's kind of complicated because you can't just take a digital signal and stick it on top of a power supply line that is in many cases very dirty power, meaning that the power supply line is supposed to be a nice smooth AC curve. If it always was a nice smooth AC curve, all we'd have to do is ride that digital signal on top of it, like a sled. And it would be wonderful, okay? But the supply line itself is jiggering all the time. And if you turn on a big nasty machine in the building or a set of air conditioners or something like that, now you get even more jiggling. You get spikes and everything. That the receiver is going to say, is that a signal? Is it not a signal? I don't know what that is. So it's really difficult. You have to figure out ways to get around this. In the past, some of the ways to get around this have been used in commercial operation, but they were very expensive. You had to have a modem on one end, and another modem on the other end, and the two modems had to talk to each other across the supply lines, and it was real expensive. But we do have it now. And here's in a nutshell how it works. In most situations where this is being employed, including my companies, this is how it works. There's your AC line, and no, it doesn't look that clean, but I'm just going to leave it clean so you can understand that we're using the AC line. And we cut a little chunk off of it at the zero crossing, right in front of the zero crossing. We take a little piece out. The receiver interprets that as a glitch in the line, and it says, oh, I wonder if that's a message. Somebody trying to message me? Why is the line not a perfect sine curve right now? Okay. Well, if we just left one of those glitches there, then every time there was a glitch in the line, the receiver would think it was getting a message. So we have to now add a few more in sequence so that the receiver can verify this is in fact a message, it's not a mistake, it's not a glitch. So what's happening now is I'm getting probably 4 sequences in a row of a perfect little chunk, not enough to even affect anything power-wise, of a perfect little chunk of our sine wave being taken out. And that tells the receiver, oh, I saw 4 in a row. This is a real message coming. And they'll now interpret the next 16 sine wave portions as a 16-bit message. Okay, so whether there's a chunk there or not a chunk there could mean it's a 1 or a 0. And it'll interpret the next 16 as its message. So now we've got a 16-bit message coming. I'll tell you almost, I'm going to say any lighting control scenario can be configured with a 16-bit message. Now, how do we achieve interoperability on this? And one of the ways is this. Most of the lighting in commercial buildings works on 0 to 10 volt dimming, right? So you've got a gray wire and a purple wire, and it's expecting to see a 0 to 10 volt signal on that. We have designed a little module, about that big. It can go either into the ceiling next to a fixture, or it can go into the fixture itself. And it translates our power line control signal from the power line controller, that device you see on the left, which is a wall switch, into 0 to 10 volt signals. Right? So out from our wall switch, through the supply wires to that little module, and now our fixture understands everything we're trying to tell them. We want you to be half dim, we want you to be full bright, we want you to be off, we want you to be quarter dim. It'll do it. We can also do color change with this, just by having 2 0 to 10 volt signals come out of that module, going to the 2 sets of different color LEDs inside the fixture. And we mix those using the controller, and we can do circadian rhythm. We can do color change, we can do room adjustments, anything like that. There it is. Okay, so what's the catch? So the catch is there are some challenges with this. It's a little different from Bluetooth. Number one, it's a little slow. So imagine that we're operating at 60 hertz, which is what power in the United States is, 60 hertz. There's only 2 half sine wave cycles that we can use for a message in every cycle of that 60 hertz, so we can only send 120 bits per second across this. Okay, now that's really all we need. And our original units actually used a lot of those bits just for verification purposes. So it turned out that when you hit the dim switch, it would take like a half a second before it would start to dim. That doesn't sound like a lot of time, but for you and me, it's an eternity, because it's like I just hit the switch, it's not doing anything, and if you hit it again like that, and now you completely screwed up the message, right? So we're faster than that now, and by the end of this year, we're going to be 3 or 4 times faster than that. Just this technology is going to continue to evolve, and it's going to get faster and it's going to get smarter. Just suffice it to say that we won't be streaming Netflix over the power supply wires anytime soon. So that's one, limitation. Physical barriers are another limitation, and this is the reason why a lot of companies decline to even get started in this. They're like, oh, this is great, but how do you jump across a transformer? How do you get past a circuit breaker somewhere? You can't. You can't. Not without using either a wireless to jump it or an actual wire to jump it, which would be illegal. But the point is this, that back in the day when we first started designing all these control systems, we thought we wanted in every application a mega control system. You picture a guy in this building where there's thousands of rooms, sitting in the basement, with some kind of set of headphones on, controlling the entire building from there. That's really not what the market wants. In some cases, the market wants that. Google probably wants that. But not the classroom in your town. What they want is a room solution. This is a perfect room solution. It's a limitation. We can't do Google with this, but there's a huge market for this, especially I'll talk about some markets where this is really, really important. Okay. Any questions so far on any of this? Yes?
Are you going to talk about zoning or grouping that later?
I'll talk about it now. I will tell you that we are not there yet on zoning and grouping. Actually, we can do grouping. And we can do addressing, but it's one way. So we can configure light fixtures and light bulbs to only respond to certain bit number commands, right? Which allows us to then say, okay, I can turn those 4 lights on, but not those 4, and they're all in the same circuit. All right, but what we can't do yet is two-way communication, where the controller is talking to the fixture, and the fixture is talking back to the controller. That we'll have by the end of the year, and that will open up a whole lot of vistas for us. Then we do any kind of controlling, any kind of zoning and grouping that we want to do. It makes the controller itself a little less simple. Right now, we try to keep our controllers, just as a matter of market preference, we try to keep them very, very simple because people want invisible, right? If you walk up to that controller and you don't know how to work it, you're not going to go ask the maintenance building guy for a manual and learn how to use it. You need to be able to intuitively use it, right? Once we get into zoning and grouping, now we have to have a way of configuring that, and that would probably be through Bluetooth. Here's where our hybrid comes in. Okay, our hybrid comes in when we take a controller, like that one, and we put a little Bluetooth chip in it, and we have it talk to an iPhone. Start on the lighting. In which case now I can use an iPad or a smartphone, and I can configure my room to the configuration that I want. Anytime the photo control sensor picks up light out of that window, it turns off the lights all along this side of the room. All that's capable of being done. We would have to Bluetooth A over to the sensor and B over to a phone so that we can configure that. I think it's an awesome solution, actually, because now it creates the reliability between the controller and the loads, and it also creates all the different functionalities that we need. Any other questions for it? Yes?
Would emergency lighting work the same way with the system, or how does that?
Would emergency lighting work the same way with the system? I'll tell you that we have an emergency light that we use that will work with the system. So what are the real, yes, sir?
Is there more of a delay with the emergency lighting? Is that not message at all?
No.
No.
No. Controller, send the message, yes.
Is there any physical concern about the existing wire, whether degradation or the size of the wire initially?
That's a really great question.
On the circuit?
There's rarely a concern about degradation, except that the same concern that you would have if you were retrofitting new fixtures and say, how good are the wires, mostly from a fire and safety standpoint, but what you would be concerned is how good is the ground? Because the signals that we are using and that anybody would use in this technology require a very clean ground. And not all buildings have a clean ground, right? So we do have a 3-wire device which uses the neutral to create its clean ground. And those devices, if there's a neutral in the building at the switch, very often there's not a neutral at the switch. But if the neutral is there at the switch, it gives us a really, whether there's a clean ground or not, it gives us a really good working system. If you're using a switch where you can't pull any new wire, and you don't want to, the whole purpose of this is not to pull any new wire, and it doesn't have a neutral, you got to make sure that the ground is clean. And there's ways to do that, as part of the installation, and we have little test devices that we're developing right now for the installers who can just, check the ground and make sure it's clean enough to give you a signal. They'll actually try to send a signal and look at it and go, yeah, you got a good signal there. Good question. The other thing is, will the codes allow it? Mr. Duffy, are we going to have trouble with the codes on this? Okay, applications. So here's some applications that are just crying out for this. A lot of people are, just learning about this, but as we bring them to these situations, they're immediately like, oh my gosh. So, concrete construction and prohibitive wiring areas, somewhere where it's really hard to pull wire, or you've got to mount that wire to the outside of the wall because it's concrete construction, something like that. If there's already wires running your lights, you can control them using this technology. High security areas, prisons and government buildings. Government buildings, will not put Bluetooth in, at least not none of the ones we've spoken to. So we actually brought this to the Navy because we sell military equipment to the Navy, our company does, and they were kind of blown away by it. It's not going to start going into warships anytime soon because you have to go, we would have to make our controller mil-spec compatible, which means, you have to be able to hit it with an atomic bomb and it still works. So we're getting there. Areas with high levels of electromagnetic interference. Anybody ever tried to run a Bluetooth device at light fair? Every time we bring our last year we had a robot, right? We had a robot that does UV disinfecting, and it works on Bluetooth wireless controller. We literally were standing 5 feet away from the robot, and it would not respond. Or when it did respond, it did exactly what we told it not to do. And that's because the saturation of wireless signals in that room during light fair is insane. So, just not a good environment for Bluetooth. Well, where else does that happen? On a ship, conning tower right there, it's just being bathed in radar and every other type of, horrific wireless thing. Places with tricky control problems. I mean, you could put, 50 different Philips Hue lights into that chandelier, but then you have to configure all 50 of them. Whereas, take it across the supply line and it controls the fixture. That's a UV light on the right-hand side, so you've got UV that you might want to turn on and off independently inside the fixture of the actual white light that's in the fixture. And we have a solution that does that very easily. It doesn't matter how the fixture's configured, we can connect our system to it and control those two types of light independently. So that's power line communication for the lighting industry in a nutshell. It is in its initial stages, although our system has been tested and it works. If you have any other questions, I'll be happy to take them. Yes?
In the case of the Philips Hue lamps and the chandelier, is the signal fast enough to handle chasing of colors? Where it's not static color or multiple static colors, it's like transitioning from red to blue to purple, like continuously?
That's a good question. I don't know. I would imagine that it is, because the delays that we experience in the system mostly have to do with waking up the system and telling it to start looking for signals. Once it does that, then it's getting signals rather quickly. And actually, we're making it faster and faster, I won't tell you how.
You mentioned dirty color being a problem. What percentage of the buildings out there, are not fair game because of
Well, let me start. So the question is about dirty power and what percentage of buildings are out there that have that problem that would make it not fair game. Actually, it is fair game. Any problem, any dirty power situation, unless it's really horrific, we can handle because we're not floating the signal on top of the sign. Okay, past attempts to do this have been trying to use that type of a technology, and the number of buildings it's not even the number of buildings, it's what's going on in the building, it's what's going on around the buildings. Even a building like this, if they're turning their transformers on and off, or they're turning the lighting phase on and off during some course of the day, that's going to send a signal that's going to disrupt the power lines in the building to the point where it would interfere with anything floating on top of the sign.
Scheduling and like sensor integration.
Scheduling is very simple with a clock inside the controller.
So what would act as the time authority? The wall switch itself, or?
It could be done a number of different ways, depending on how accurate you want it to be. Right? We actually have one system that we set up as our circadian system that's not even using a clock. Basically what it's doing is you press the button in the morning and the software times itself and cycles through the circadian from morning till night. If you were to turn it off midday and then come back maybe 1 o'clock in the afternoon, turn it on again, there's another button you can push to tell it that it's afternoon, and it will cycle from there all the way into night, and there's another button for nighttime. So that's a way of doing it without even a clock. And then you can get more and more sophisticated by adding a clock into the controller. Now you can, and then maybe, figuring out a way to get the clock to set itself by Wi-Fi or something like that. There's a lot, you can take it as far as you want. Yes?
So what I'm picking up from you now is the difference between the 1970s X10 and 11 DHC system, which sent a signal on top of the sine wave, is that you're altering the sine.
Yes, that's right.
Because with the X10, we had a lot of interference problems which couldn't be overcome.
Right, and unfortunately we have that sort of that stigma now because people are like, oh my gosh, power line communication, don't put me through that again.
Right.
All right, but this was designed specifically for lighting applications. It was designed specifically to alleviate the problems you're talking about, the X10, all that. And it's it works really well. You can demo it for you anytime you like. Yes?
You mentioned individual control and one, individual fixture control and one controller. How many can I get on one controller? Is there a limit?
There's theoretically not a limit, right? I'm not really sure.
150 lamps. So it depends on the amperage and the voltage. So if you're running 220, you're not going to run. You could do this room pretty easily.
Yeah. Yes?
What kind of keypad configurations do you have? Is it just a one set, option, or do we just?
Our initial launch is 2 different option sets. One for basic on-off dim, which is great in those cases where all you really want to do is, control the lights without having to pull 0 to 10 volt wire. And another is for circadian color tuning, which has the sequencing I talked about in it and the different buttons you can push to tell it what time of day you want it to cycle from. And also, there's 2 pads on the controller that will allow you to set the color temperature right where you like it if you want to leave it static. Yes?
You're also doing a hub?
We will ultimately be doing a hub. We don't have a hub right now. Yes?
Multi-applications, could you do a full color fixture possibly?
Yeah, we actually have, right now we're tuning white light with it because we think that's the market we should jump into at the outset. But yes, we can do full color. We have systems doing full color right now in the lab, right? Or somewhere. Yep. Okay. Any other questions? That's it. Thank you very much. If you want to talk to me after this.